Alright, how are you guys doing? I haven't made videos for a long time. It feels like coming back home. What a pleasure. Alright, today we're doing integration using U substitutions, and this is not meant to be your first go at it. Hopefully you've seen them before. This is just a little review for you. Maybe you're taking Calc 2 class or something like that. Alright, let's get to it. Let's review the main idea. The main idea is that you start off with some integral with all kinds of x's, and often you may be stuck and you say, whoa, I don't know what to do with a bunch of x's. The brilliant idea for U subs is that you can imagine or invent some sort of dictionary for use, some sort of substitution, a translation, an exchange rate with u's and x's. This comes out of pure imagination or invention, or you could just copy somebody else who's done it already before. If that's how you roll, hey, more power to you. I'm just kidding. There's some brilliant substitutions where it's amazing where it all comes from, and you just can't help but copy great people who have come up with these. So once you've got your dictionary, then the next thing you want to do is maybe complete it. Often that requires that you do the differentials on the dictionary so that you can figure out how much every dx is worth compared to a du. And often that also means that sometimes you have trig functions. You should also include a little trig triangle so you can make that part of your dictionary. Often you have to exchange a sign for cosine and whatnot, and the dictionary and the triangle will be useful. In any case, you complete the dictionary, you make all the exchanges so that you have no more x's, just u's, and you inspect it. Say, hey, now I've got the same integral but with u's, a u version of the integral, and hopefully it's an easier one that you can do, and that will be the end of it. You'll be able to do it. So let's just start off with a classic example. Maybe the most classic example is something like this: the integral of e to the 5x. So you could start off let's do, so the idea again was that we invent some sort of substitution, some sort of dictionary. I'm going to invent this dictionary. I'll put it off here on the side here. My dictionary is going to go like this. Every u is going to be worth 5x. And the reason for doing that is because I see the 5x here. I say, hey, wouldn't it be nice if that was just e to the u instead of 5x? That would be nice, right? In fact, that might be the first part of your substitution. Instead of 5x, I've used my dictionary. Every u can be exchanged for 5x's, or every 5x's can be exchanged for u. Complete the dictionary, slap a d on both sides. D of u is equal to 5 d of x. That tells me the exchange rate between the dx's and the du's. Every dx can be exchanged for a fifth of a du. And so I'll go here and I'll replace my dx with the right exchange. So the integral becomes that, it becomes e to the u times 1/5 du, which I can clean up just a little bit if I wanted to, e to the u du. And now we're at the point where we make a judgment here. Is this integral, wait, that's not the kind of teacher I am. How about that? Does that look better? You look at that and say, hey, is that an easier integral than the one I started off with? And if things are going your way, maybe it will be. That wasn't me, I'm just moving the screen. Alright, so this would become 1/5 e to the u plus a constant. And it's customary when someone asks you a question in x's, you should maybe be polite and answer with x's, not with u's. So they asked us about x's, we should answer with x's. Go back to the dictionary and convert to x's. This would become 1/5 e to the 5x plus a constant. There it is. Easy, huh? That's a little review.